Okay, so we're going to start. So, hi everyone. Today we're just gonna be talking about a really interesting node that is the curved tangent node. Um, in case you don't know it, basically this node is just gonna be like providing you information of the tangent of the curve. Okay. In case you don't know what is like the tangent of a curve, it's just basically like the direction of the curve, okay, at each point. So the tangent changes with the curve, okay? You can see it here, for example. This is the curve, and this is the tangent of the curve. This is the direction that the curve is going to, and this is the normal. This is the normal that is like it goes it has like 90 degrees in relation to the tangent. Okay, that's basically it. Okay, let's just go to the manual just to check something, and we can go ahead and it really made it simple for you. So I'm going to be showing you what this node does. Okay. So, okay, let's just go ahead and start with it, okay? So we're just gonna be like um, maybe creating a new file where you just we're gonna do this again. So let's just create a new file and let's just go to geometry nodes and create a new node, and then we will have just to disconnect this here, okay? And we're just gonna be adding a spiral. So let's just shift A and then curve, and then curve primitives, and then let me see, curve spiral. Perfect. And then we just we're gonna use just to see what this node does. We're gonna be using the sample curve node. So just in case, I have a list of all of the different geometry nodes in a playlist in my channel, and it's also in the description, so you can be able to find it. Okay. Okay, so let's just sample curve node, and let's just move it here. Let's just connect it. Um, this is not gonna be doing too much right now. And let's just add points. We're just gonna be adding points here. Okay, so we have a point here, and that's it. That's what we're gonna get. And but we're gonna be moving the position like we can start like putting it according to the position of the curve. Okay, so if you remember, this node is gonna be basically moving the point according to the position of the curve. Okay, so now we're gonna be adding a join geometry node. So shift A and geometry and join geometry. Perfect. We just added that node. Let's just activate this. Perfect. And we're gonna also be able to see the curve. So this is our curve. It's a spiral. So um, basically, we're gonna be just moving the point according to the points of the spiral. Okay. But let's just check what happens if, for example, I just change the position of this point to tangent. So it's gonna be moving according to the tangent of the spiral. You can see that it's different. You see, like it doesn't goes up that much. So what is going on here? You're gonna be able to see is that if we, for example, add a set position node like here, yep, and we add the curve tangent node. So curve tangent, that is here. You're gonna be able to see that this curve is gonna like it's gonna move to the position of its tangent. Okay, so here is the tangent. Okay, like this is the different positions that the tangent has according to like as according to the length of the spiral. So what is going on here is that the spiral is like having the information now, like the position of the tangent of its tangent. So and you can see that the point it's also having the position of the tangent of the spiral. Okay, so that's basically it. So this curved tangent node is going to be giving you the information of the curve that is connected to the node where um, where this node is connected. Okay, so that's basically it. Let's just check what the manual has to say. um, it's not that much actually, but it says like that the curve tangent node outputs the direction that a curve points in at each control point. Like that is the tangent, the direction of the curve. Depending on the direction of the curve, which can be controlled with the reverse curve node, the output values are normalized vectors. That's um, that's like information that we already know. And this is really interesting, this warning, because it says that for NURBS and Bezier spline curves, keep in mind that the value retrieved from this node is the value at every control point, which might not correspond to the visible evaluated points. For example, a Bezier spline might have 48 evaluated points, but only 4 control points. Its resolution is 12. For nerve splines, the difference might even be more pronounced and the result might not be as expected. A resample curve node can be used to create a polyspline where there is a control point for every evaluated point. Okay, so what this is saying, and let's just try to see if we can see that happening in the spiral. I think that we can. Is that, for example, if we decrease the resolution a little bit, um, something sort of like this. Yeah, and we start moving, for example, um, this little point according to the factor. No, we can see it here, but let's just try by um, let's just try by connecting this here to see if we can like get something different. Well, no. Um, hmm. Well, the thing is that basically, this node it's gonna be like the movement. It's not gonna be exact because the points are just not correlated. Okay, and that happened with that those two type of um of curves. Okay. What else? Well, then it's just like the input, but the node has no inputs, has no properties, and the output is just like the direction of the curve at each control point. I mean, you need to keep this in mind because it's really gonna be depending on the control points of the of the of the curve. Let's just try. Maybe we can try um with a Bezier segment or something. Let's just see and let's just connect this here, for example. So I think that we can. Yeah, I think that this is the one. Let's just see. You see that at this, for example, this point is just not moving exactly according to the curve. Is because of that. Because like the resolution is not that much, so it doesn't have like the same um information, you know? Like if you see it this way, it moves exactly the same. But But here is moving like according to the tangent. Like the thing is that the sample curve node, um, it it moves. I'm sorry, the sample curve node, it moves according to to the tangent like really specifically, you know. But in the case of this other node, like the tangent node, is taking the tangent at just at the control points. Basically, the control points are like this point and this point. I'm sorry. Yeah, yeah, there are two actually. Yeah. So we can like increase the resolution. I don't know if that's gonna work. I don't think so, but let's just check. Actually, no, it's not gonna work because the resolution is actually the problem. You know, like it's divided in more pieces, but because of the resolution, not because of the control points. I think that you see, there is no way to um, get the position according to that tangent, and it's because of that. Okay, so you might be disappointed or something like that. So that's why this you have that warning because you can like use as they said, like as the manual says, you can use the resample curve node and you can turn it into a polyspline. Okay, but that's a whole different process. So let's just, for example, use that node. So curve, um, resample curve, and let's just connect it here, maybe. Yeah, and okay, let's just add a little bit of more resolution, and let's just see. Uh, well, this is more like approximated, I guess. Mm, let's just try to use this node uh like here to see that everything's alright. Okay. Yeah, you can see that now they have like um the same tangent because like now it's a polyspline. So it doesn't like it is having more control points and all of that. So they have the same tangent. But in other cases, basically the sample curve is gonna have the tangent at each point of the curve, like at each in distance at each point, while the curve tangent is gonna have like the tangent of the curve, but only at the control points. Okay, that's the difference. And it's an important difference. Okay, so. Well, that's basically it. Thank you for watching this video and see you in the next time.